We're going to look at adding and subtracting radicals as well as multiplying radicals in an applied format. So what we're going to be working with is similar to polynomials, just area and perimeter, but our measurements are going to be radicals, and so that's how we're going to see adding and subtracting and multiplying be applied here. So one thing we need to remember, perimeter for all types of shapes, so all shapes, is the sum of all sides. So when looking at objects like example 1, the perimeter of a rectangle, one thing we have to make sure we keep in mind is that there are 4 sides, even though we don't see all 4 sides labeled. We just need to remember that opposite sides are congruent. That means the same length. And so whatever we see on this side of the rectangle is going to be the opposite. So if I'm writing the perimeter, the first part of my equation I'm going to write is just adding all 4 sides together. So that means I'm going to have a root 24 plus another root 24 for its opposite side, a root 27 plus 2 root 3, and another root 27 plus 2 root 3. So it might be a little lengthy. And what we're going to do is combine like terms to start. So if you look, you have 2 root 24s here. Here you have 2 root 27. And then here you have 4 root 3. So this has simplified the expression for ourselves, but we still need to simplify each radical to put it in simplest form and see if there's any other like terms. So 24 breaks to 2 and 12, 2 and 6, 2 and 3. So the 2 comes out for a 4 on the outside, so 2 times 2 is 4. So I'm going to write my answer up here since I'm running out of room, so that's where I'm putting this. So we have a 4 root 6. Now, here we have a 3 and a 9, a 3 and a 3. The 3 comes out to make a 6, and we see that we have a root 3. So because this one simplifies to 6 root 3, and I also have another object as a root 3, these two are going to combine. So 4 and 6 is going to add to 10 root 3. So this is going to be my final answer. 4 root 6 plus 10 root 3 is the perimeter. So same thing with example 2, although we don't have a picture, it is telling us the shape, so we should know exactly how to set up this problem because it'll be the same as the one before. The perimeter of a rectangle has a length of root 8 and a width of 2 root 54. So we know that there are going to be 2 of each because a rectangle has 4 sides, opposites are congruent. So I'm going to have a 2 root 54 plus another 2 root 54, a root 8, and another root 8. So combining like terms to start will make it a little simpler for us. So 2 and 2 makes 4 root 54. 1 and 1, so 2 root 8. And now I'm going to look to simplify. So 54 is 2 and 27. 3 and 9, 3 and 3. The 3 comes out. 3 times 4 is 12. And I have 2 singles, so 2 times 3 is going to go back inside for root 6. 8 is 2 and 4. 2 and 2. We have a pair of 2's that will come out. 2 times 2 is 4, and then my single, so the inside is 2. So I do not have any like terms to combine here, so this is my final answer. Now, if I look at this next one, we are working with a square, so we can see that only one item or one side is labeled, but what we know about squares is all sides are congruent, so that means we are going to have 4 of these root 45s. So we could originally start like this, adding all the root 45s together. However, we know that there's going to be 4 of them. The coefficient is 1, so 1 plus 1 plus 1 plus 1 is 4 root 45. So if you're able to kind of make that connection when you're starting the problem, instead of writing everything out, you could go ahead and combine to make your space a little saved here. So 45, we need to simplify that now. That's going to break into 3 and 15, 3 and 5. 3's come out, so 4 times 3 is going to give me a 12. My single is the 5, so it simplifies to 12 root 5. All right, try number 1 on your own. First of all, let's note that it is a square, so it's going to be exactly like example 3. So go ahead and try 1 on your own, pause the video, and then start it to see how you did. So with our square, we have a root 32, and we know that all sides are congruent. So just like this first one, we have 4 of these root 32s, so 4 root 32. 2 and 16, 2 and 8, 2 and 4, 2 and 2. You have a pair of 2s and another pair of 2s that will come out. Whenever I have more than one, I still just like to write it all out for myself so I don't forget anything. So 4 times 2 times another 2, and then root 2. That single goes in. So this will multiply. 4 times 2 is 8. 8 times 2 is 16. Root 2. So try number 2 on your own as well. Give this one a shot. It is a rectangle, so pause the video, try it, and then check your work. So try one more on your own with number 2, and then we are going to look at area. Okay, so perimeter of a rectangle, we just have to be a little bit more careful with this one because this one is one term, but this one right here is 2 terms, and with a rectangle, we need to write both of them twice. So we have root 12 plus root 12. We have 2 root 27 plus 4, that whole side, plus another 2 root 27 plus 4, so that side again. Go ahead and combine like terms. So we have 2 root 12. We have 4 root 27, and then 4 and 4 make 8. So simplifying, 12 breaks into 2 and 6, 2 and 3. Couples go out. So we have a pair of 2s, so 2 times 2 is 4 with a single 3 that goes back in. 27 breaks into 3 and 9. 9 breaks into 3 and 3. So we have a pair of 3s that will come out again. 3 times 4 is 12 with a single 3, and then that 8 will come down. Now, we've seen this before with simplifying radicals. We can have like terms, so we always want to double check after simplifying. So this 4 and 12 will combine to make a 16 root 3 plus 8. Look at area. So remember, area is different for different objects. So today what we're just going to focus on are rectangles and squares. So those are the easiest formulas to remember because rectangle, square, their area is just length times width. And that's it. So we've worked with that before as well. So when we're looking at these problems, though, we need to be a little more careful because we have to kind of evaluate how many terms we're working with. So this width is a 2-term piece, and this is a 1 term. So I am going to write this length times width with the 1 term in front, and then you cannot forget your parentheses if there's something with more than 1 term. So 3 plus root 3. So then now that it's set up, I'm going to multiply, and you can either use distribution or box method. So here I'm just going to distribute. Outside is 1. This is considered an outside, so that makes 3 root 15. Outside 1 times 1 is 1. Inside's 15 times 3 is 45. 15 breaks into 3 and 5, but nothing comes out, so we just bring it down as 3 root 15. 45 breaks into 3 and 15, 3 and 5, so we get a 3 root 5. Always double check for like terms, but this is a 15 and a 5, so we are done because they cannot combine. So next page, same idea. So we are going to find the area of the rectangle. Now, it did get broken up in your notes, but that is a minus root 7. So I'm just going to rewrite that here so you can see it as one thing. And then the width is another 2 terms. So this is where we really need to be careful because right now we have a 2 by 2, the 3 root 4 minus root 7, that's the length, times the width of a root 2 minus 2 root 6. So 2 by 2, I'm just going to go ahead and do box method. I think that just keeps things a little bit cleaner. So I'm going to label the left side 3 root 3 minus root 7. Tops are going to be root 2 and negative 2 root 6. Multiply into the pathways, and remember if you don't see a coefficient, it's 1. So 1 times 3 is 3. Insides 3 times 2 is 6. Outsides 3 times negative 2 is negative 6. Insides 18. Outside, negative 1, 2 times 7, so inside 14. And the last one, negative 1, negative 2 is positive 2, 7 times 6, 42. So here we see we have absolutely no like terms, so I'm going to bring everything out, but we should see that since some of these are larger numbers inside, we could simplify. So we are going to look for that. And maybe we'll have like terms after. 6 breaks into 2 and 3, so nothing happens. 18 breaks into 2 and 9, 3 and 3. The 3's come out. So this is going to be a minus 18 root 2. And then I'm just going to go ahead and bring down that 3 root 6 as well from the front. So 3 root 6 minus 18 root 2. 14 breaks into 2 and 7, so nothing, so minus root 14. 42 breaks into 2 and 21, 3 and 7. Nothing combined, so it remains 2 root 42. And so I have no like terms, which means this is actually my final answer. There is nothing to combine. So the last thing is squares. So with a square, we just remember that the sides are all the same. So length times width, it'll be the length times itself again. So when I'm writing this, I'm going to write this twice. 4 root 2 plus 5 root 2 times a 4 root 2 plus 5 root 2. Again, this is a 2 by 2, so we are going to draw a box. So I'm just going to draw it down here and label 4 root 2, 5 root 2. 4 root 2, 5 root 2. And then multiply. Outside with outside, inside with inside. So it's just very repetitive. So 16 root 4, 20 root 4. 20 root 4, 25 root 4. So a lot of the same roots. And that's because these were originally root 2. All we had were root 2, so they all multiplied to root 4s. So we have all these like terms. So 16, 20, 20, and 25, you can use a calculator for that one because we're going to add all their coefficients when we bring it out. So we have 16 plus 20 plus 20 plus 25 is 81. So we have 81 root 4. Now we do have to check for simplifying, and 4 does break into 2 and 2. And so this is actually a perfect square because all my couples will come out. So 81 times 2 is 162, and that is the area of our square. So try number 5 on your own, see how you do, and then we'll check. So pause video, try on your own. Okay, so another 2 by 2, negative 5 root 2, 5, 3 root 2. We get a negative 25, negative 15 root 2, negative 25 root 2, and negative 15 root 4, because inside root 4. So we have like terms here. So when I pull this out, I'm actually going to go ahead and combine like terms. Negative 25, negative 15. We get a bigger negative. So this is a negative 40 root 2 minus 15 root 4. And we should remember from the previous problem, 4 simplifies as a perfect square. So this gives me negative 30. And when I bring all of this down, what we should see is we have another set of like terms. Negative 25, negative 30 should combine. So we end up with a negative 40 root 2 minus 55. So try this last one on your own. Try number 6. Pause the video, try it, and then check your work. So Susan is working with a square garden, which means length times width should be the same two things. So we have a root 5 minus 4 root 3 times another root 5 minus 4 root 3. Box method, write the same thing twice, right? Root 5, negative 4 root 3. Root 5, negative 4 root 3. Outside with outside, inside with inside, negative 4 root 15, negative 4 and another root 15, positive 16 root 9. Like terms, so we can combine those as they come out. So we have 1 root 25 minus 4 root 15. So actually, I'm just going to go ahead and combine that now. So minus 8 root 15 plus 16 root 9. 25 is a perfect square, so this becomes 5. And 9 is also a perfect square, so we are going to multiply 16 times 3. That gives us 48. So positive 48 comes down. So we mentioned this a couple times now that after we simplify, we want to look for like terms again, and we do have a pair. So this is going to be negative 8 root 15, and then 5 plus 8 is 48 is a 53. Okay, and we are going to leave the last two for class.